Sir, with what topic you started today?
Same. Previous topic only. Elevation boiling point, depression freezing point. I'm adding one more parameters, entropy parameter in it.
Okay, sir. Okay.
Right? See, sir. In case of when I am studying elevation boiling point, which is high, entropy of solvent, change in entropy of solvent is greater than solution. When I am studying depression in freezing point, which is high. Observe these two carefully. Solvent became less than solution, right? So this is in case of depression in freezing point. Means what do you write? Delta TFA. That is in case of delta TB. In case of delta T, when I am studying elevation boiling point, entropy change of solvent becomes greater than solution. When I am studying depression in freezing point, entropy change of solution becomes greater than solvent. Reverse. Sir, if delta S solvent becomes equal to delta S of solution, then what is the meaning of it? If both becomes equal, then what I am studying about? Are you able to understand the question? If a solvent is less than solution, it is depression freezing point. If a solvent is greater than solution, then it is elevation boiling point. If both are equal, then what I am studying about? If delta S of solvent becomes equal to delta S of solution, that means what I am studying about? Immiscible solutions. Or if they are not miscible at all, they exist as individual components, right? If they behave as pure solvents or if they behave as solution, in both cases, there is no mixture formation. If there is no mixture formation, there is no change in entropy. When there is no change in entropy, what happens to delta S of solvent and delta S of solution? Remain same. Means I am studying about immiscible solutions. If it becomes equal, immiscible. If they are not equal, definitely they are solutions, miscible solutions. If they are miscible solutions, then either elevation boiling point happens, depression freezing point happens. Then accordingly, the delta S parameters will change. Clear? Do you have any questions or queries about this idea? Respond. Do you have any questions regarding this?
No, sir.
Now I am coming to next thing. Experimental method of determining molecular weight of unknown solute. By using relative lowering of vapor pressure, already we have studied it. Now we are doing that by using elevation boiling point and depression freezing point concept, right? So I am using that method. Experimental method of determining molecular weight of unknown solute. In this, already we have studied one method. What is that method? Already we studied one method, sir. What is that method? Ostwald-Walker method. Studied or not? By using Ostwald-Walker method, what we have done? Ostwald-Walker method. What we have done, sir, in this method? We calculated relative lowering of vapor pressure. By using relative lowering of vapor pressure, we have found the molecular weight of unknown solute, correct? I will show that again. If you don't read the notes on daily basis, every week it becomes a new topic. What we will do? These questions also we need to discuss. See, this is Ostwald-Walker method or not? In Ostwald-Walker method, what we calculated at the end? Determination of molecular weight of unknown solute by using relative lowering of vapor pressure. Correct or not? So Ostwald-Walker method is used to determine molecular weight of unknown solute via a relative lowering of vapor pressure. Correct? Next method we are talking about. We are talking about next method, sir. What is the next method? Rast-Camphor method. Rast-Camphor method. This is one method. Another method, Beckman's method. Fourth method, Berkeley-Hartley method. The spellings may be different, man. Huh? Okay, let me check the spellings also. Name of the scientist. Huh? Just a moment. One method is Rast-Camphor method. Okay, what? Rast-Camphor method. Spelling is okay. Let me copy the image also at one go. It will be over. I will take this image. Huh? This image seems to be better, right? But it is Beckman's method. Diagram. They haven't given anything else. But it is not clear now, this image. It is blurred image, it seems. This is also Cortel's Beckman's method. This is. This is also there. Rast-Camphor method diagram is not there. In total internet completely it is not available. Right? What we call apparatus, huh? Apparatus. Maybe diagram it is not checking properly. Let me check apparatus. That also not there. Can I take this one? Not happy with that image. Image itself is wrong. It is somewhat okay, but they gave Beckman thermometer, freezing mixture. Okay, no issue. But they gave freezing mixture. Hey, in our target booklet, image is there. Check. Any diagram is given in our target booklet test list. But I doubt it. They will not give that image.
Sir, no image in our target booklet, sir.
They have not given any image, huh? Very good people. Means we have to check. There is no other choice. This is somewhat apparatus for determination of freezing point. Correct, huh? I am taking this image. By using this image, I will draw that parts and so on, and we will discuss. They have given some diameters, everything. Huh? Don't worry, I will explain it. Right? Next one, Beckmann's method. That is elevation boiling point. Oh, but here they are heating. Okay, no issue. Then I can take this image. This image is better, man. Compared to this, that image is better. This is better. I will take one more image. What is it? Beckmann's method. For determining elevation of boiling point. There is also blurred image only. Blurred image is okay, but not satisfiable. Relatively, this image seems to be better, right? Comparatively. This is only better image, man. I will do one thing. Cottrell's apparatus. Cottrell's apparatus. This is Cottrell's apparatus, sir. This is. Better, I will take this image to some extent. Acceptable, right? I will better image I will draw and I will update in your notes, right? As of now, temporarily you follow this image. Next one, Berkeley-Hartley method. Berkeley-Hartley method. Berkeley-Hartley method. This one. What, Srinivasa? You are coming so late. 5:30. Okay. Right. So these three methods we need to discuss, man. Right? This is for Ras-Camphor method. This is for elevation boiling point. Right? Cortals apparatus, or we call it as Beckman's method. This is Berkeley-Hartley method. Right? So Berkeley-Hartley method is used for Berkeley-Hartley method is used to determine molecular weight of unknown solute by using osmotic pressure. Right? Yeah. మనం మాట్లాడాను అంతా ఓకేగానే ఉందా మై వైపు నుంచి ఓకే మనం ఒకసారి మాట్లాడతాం అయిపోయింది ఇంటికి వచ్చింది హలో చెప్పండి సార్ మళ్ళానా మళ్ళా ఏంటి ఓకే ఓకే ఆర్టీసీ అప్రూవల్ కోసం ఓకే సరే 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 నేను మళ్ళీ చేస్తాను మళ్ళీ వస్తుంది సరే నేను ఒకసారి సార్తో మాట్లాడతాను రైట్ నౌ సీ దిస్ experimental method of determining molecular weight of unknown solute. Ostwald-Walker method is used to do that by using relative lowering of air pressure. Ras-Camphor method by using depression freezing point. Beckman's method by using elevation boiling point. Berkeley-Hartley method by using osmosis pressure method. Right? 4 methods. In which this method is already done. Correct, sir? Now we need to see the remaining methods. Before going to that, in order to understand Beckman's method, we need to understand two equipments. One is called Cortals apparatus. Another one is Beckman thermometer. If you understand these two apparatus, then only you will understand what happens in Beckman's method, right? So first, let me explain those two apparatus first. Beckman thermometer. Observe the difference between normal thermometer and this Beckman thermometer, sir. Have you found any difference? Okay, I will do one thing. You can see this. Observe that this is the top column. Normal, you have seen thermometer, no? Right? Normal thermometer have only one column. If you observe this Beckman thermometer, you will have a reservoir on the top. Right? You can find here. Have you found any reservoir on the top? Normal thermometer, up to here it is normal thermometer only. Above that, it has a separate reservoir. Right? Clear? Is it clear now? Okay. Now, here also you will find calibration, means measurements. And here also you will find measurements. If I keep on increasing temperature, what happens? Mercury will expand, linear expansion. During that expansion, based upon to what extent it was expanded, we will measure 60 degree Fahrenheit, 70, 80, 90, 100 degree Fahrenheit, and so on. If a temperature keep on rising, what happens? It goes beyond a certain limit. In normal thermometers, we will have a limitation up to 120 or 140. You will find now up to 140 degrees. Beyond 140 degrees centigrade cannot measure. So what you will find in Beckman thermometer means you will find a reservoir here. If a temperature goes beyond 150, that mercury flows into this reservoir. Right? So in this reservoir also you will find some reading. So you will get 100 plus remaining temperature you will measure here. Are you able to understand? Similarly, 150 plus remaining temperature you will measure here. And in that way, instead of measuring up to 150, now I can enhance the temperature measurement up to 250, 300 degrees centigrade. Are you able to understand? What is the difference between Beckman and normal thermometer means? You will find one extra reservoir on the top so that the temperature what I can measure can go to a better level. Clear? Any questions are in it? No. So I call this as Beckman thermometer. Now one more equipment we need to check. Cottrell's apparatus. It is a C-shaped, or better I can call it as U-shaped some tube, right? That also let me check once. I think here you can see that image properly. Beckman thermometer. Have you able to see? We found some reservoir here. Again, calibration with some reservoir, mercury reservoir, right? One more thing we need to discuss. That is Cottrell's apparatus. So why it is not coming? Sir. Hello. Yes, sir. Game. Coming. ఏంటి నాకేం తెలియదు. మనకు తెలియదు. తెలియదు. ఓకే ఓకే సార్ నేను మళ్ళీ చేస్తాను. Hey, earlier we got man. Now it is not coming. Why? Maybe spelling mistake, huh? Cottrell's, Cottrell, C-O-T-T. Cottrell's apparatus. Cottrell's apparatus. Observe here. Inside this chamber, here you find one tube-like structure. This is Beckman thermometer. This top one is Beckman thermometer. At bottom, you will find some tube having some U-shaped tube with a stand. That is Cottrell's apparatus. They are not showing the here. See this. This is Quartles apparatus. Instead of having 2 strings, it have 3 strings. Sometimes you will can take 4 strings also, right? So this is Quartles apparatus. Only this middle part, man, not remaining all, right? Only this is Quartles apparatus, right? You can find if there is any individual image of it. I can call it as Quartles stand. Here you can see something. Have you found that this is middle one is thermometer. This U-formed U-shaped tube having a stand, right? That is Quartles apparatus. Can I copy that from here? Oh, now you got properly, man. This is Beckman's method, man. No, we'll go for that. This is only better. Understandable? Are you able to understand this? Middle one is Beckman thermometer. At the bottom, you found one stand, right? That is Quartles apparatus. I will copy this image and I will cut only up to that part. Okay, well, I will delete this. Done. This is that Quartles apparatus. What is the spelling, sir? CO double R T, double T, Quartles, CO double T R E double L. CO double T R E double L. Quartles apparatus. Now, both are kept inside a jacket, outlet jacket, a glass tube, right? And was sealed. This is a condenser in order to decrease the temperature, right? If all put together, then this is used to measure elevation and boiling point. Clear? Response, right? So for convenience, what I will do, let me cut and paste this here and let me keep this here so that everything will be visible properly. Understandable? Now, what is the use of this one? Already we discussed about the use of Beckman's thermometer. What is the use of Beckman's thermometer? In order to measure higher temperatures, right? Beyond the expansion limit of mercury, if the temperature goes further, that mercury falls into that reservoir, so then they can measure remaining temperature also. Now, this is having it is a pipe, sir. If it is kept inside a beaker, and if I am heating it, now, if this is completely filled with liquid, do that liquid gets uniform temperature or the temperature of the liquid at the bottom will be high? So temperature of the liquid here at the bottom will be high. That liquid now flows through this capillary and it will come out of this capillary. Are you able to understand? That Quartles apparatus uses, if I am heating that test tube, that fluid will go through that pipes and it will be sprayed, comes out of it from the top. Clear? Now what I'm doing, I'm keeping thermometer here. So that fluid now directly falls on thermometer so that I can measure exact temperature of it. whatever the temperature you have found at the bottom, that the temperature can be measured accurately now. Is it clear? Any questions, sir, in this? Response, sir. Do you have any questions in this? The use of Cortels apparatus, Beckman thermometer, and this total setup. Clear? So this is that Beckman thermometer. This is that Cortels apparatus. Now, for which solvent I need to study elevation boiling point, right? That I will take here. Right? So maybe it is a solution or solvent, whatever it may be. Either solution or solvent. Now, if I keep on boiling, what happened? Right? The temperature at which it reaches boiling point, you will see bubbles, right? Correct or not? The moment you see the bubbles, you stop heating, make a note of that reading. Clear? That represents its boiling point. Now we add some amount of unknown solute. You take 10 grams of unknown solute, you add that to it. Then what happens to its boiling point? Increases. Now again boil it. The moment you see that bubbles, stop, take the reading out. So you know pure solvent boiling point reading. Now solutions boiling point reading. So which gives delta TB now. Understood, sir? Any questions? Right? Respond. So by using this apparatus, what I'm going to do? What I'm going to do here? Note down the temperature at which. What I have to do, sir? Temperature reading is noted for pure solvent as well as for solution, right? For pure solvent as well as for solution. When vapor bubbles are observed at the bottom of jacket, right? At the bottom or at the bottom of outer jacket. Okay, no issue. At the bottom of tube, test tube. Can I call it as test tube, right? Or simply apparatus. Now, by using this, what we are going to measure at the bottom of apparatus to measure boiling point or elevation in boiling point. And I am going to measure both temperatures, na? Boiling point of pure solvent as well as solution. Both I am able to measure. So to measure delta TB. Any questions are online? Do you have any questions in this? Is it clear?
No, sir.
Right? Yes, remaining students respond. Bala Ganesh, Jivitradit, Sivakumar, Santoshini, Ajay Khanna.
Yes, sir.
Ajay Khanna, have
Yes,
you called
sir.
me? Ajay Khanna, have you called? He's not responding. Okay. Now, after knowing this delta TB, now come back to this formula. What do you know about delta TB equal to? Delta TB equal to I into KB into M, where I is nothing but Van Hoff factor. You know everything about I, right? So if you know delta TB equal to KB, KB is nothing but that solvent, right? So we have that data for different solvents, different KB values of different solvents. See this. Observe, all these are KB values of different solvents. Right? All these are KB values of different solvents. Observe carefully. Water. What is KB value of water? 0.52. Already we know this. 0.52 kg Kelvin per mole. What is the KF of water? 1.86 kg Kelvin per mole. Correct? Same way for ethanol, cyclohexane, benzene, chloroform. Different solvents have different KB values. So you already know the KB value and take that KB value from the data. Whatever the solvent you have taken for doing this experiment, its respect to KB values you have to consider, right? So now use this formula delta TB equal to I into KB value is obtained from this table into molality. What is formula of molality? Weight of solute, correct? Upon molecular weight of solute upon molecular weight of solute into 1000 upon into 1000 upon yes, weight of solvent. Now, while you are doing that experiment, can you get this weight of solute formula? This weight of solute value. You are doing the experiment means when you are adding that solute, you can take that weight of that solute value, right? And amount of solvent you have taken, that also known. So weight of solute is known, weight of solvent is known. K B value is obtained from the table. Delta TB you calculated by using experiment. So what is left there? Only one thing is left. What is it? Molecular weight of solute. So therefore, what is molecular weight of solute now? Is equal to I into KB value upon delta TB into weight of solute. This is also known into 1000 upon weight of solvent. Now can you calculate molecular weight of unknown solute by using elevation boiling point or not? Right? So what we call this method as? Beckmann's method, or we call it as Quaterl's method. Right? Anyhow, both I am using. Quaterl's apparatus I am using. Beckmann thermometer also we are using. Clear? Sometimes they use it to call by a different name also. 1 minute. See what they could give here. Quaterl's method. There is one more method, man. 1 minute. Experimental method of determining elevation in boiling point. What is it? Landsberger Walker method. Right? That is also same. But observe the design of it. A little different. Right? What we do is, instead of heating it directly, we will keep on sending steam. When you keep on sending steam, what happens? Steam will come out of this outer jacket. Then what happens to temperature of this bulb inside? Rises, right? The moment you see the bubbles, by you in this thermometer, note the value. Are you able to understand? Instead of directly heating, we are allowing either some hot liquid or maybe steam through that. Response, sir. So what we got as Landsberger-Walker method, right? Lansa, L-A-N-S, N-D-S, Landsberger. Landsberger-Walker method. This is also to determine what? Delta TB only. Right? Any questions, sir? Clear about this idea? Okay, what? This is to determine molecular weight of unknown solute by using elevation in boiling point. Now I am coming to next method, sir. What is it? Rast-Camphor method. Right? Better, I will keep this that side. Now I am coming to Rast-Camphor method. I am taking this image from here. I will delete this. No confusions now. Respond, man. Right? I am not confusing you, right? What is this one? Rast method of determining right? Simply I will write delta TF. Will you understand if I write like this? Say something, right? Now observe this setup, sir, carefully. Now this is one glass beaker. Inside that I am taking water. So that's why I call it as water bath. Now, if I heat, which will be absorbing the temperature, water. Now, water will give temperature uniformly throughout the volume of this test tube or not? Or if I directly heat it, what happens? Temperature at the bottom will be more compared to top. Now, if I am heating water, temperature of water is rising means what it will do? It will distribute the temperature uniformly throughout this jacket or not? Now, observe one spatula here, one ring here, right? Which I can oscillate, keep on oscillating, so that this mixture will be, or that components will be mixed properly, so that uniform distribution of temperature happens, right? Now I will take either camphor or naphthalene or anthracene or phenol, any compound, right? Some solid. That solid should behave as a solvent, right? Are you able to understand? I am taking camphor first. I will seal it. And if I keep on increasing temperature, at some point that will start melting, right? The moment it starts melting, till that it will be turbid. Camphor is white color solid, na? So till that extent, or benzoic acid I have taken. Benzoic acid is nothing but crystals, white colored crystals, right? So when I keep on increasing temperature, it remains as a turbid. When the moment we reach melting point, when it starts melting, that becomes transparent. The moment it becomes transparent, I can see the readings of thermometer. Till then, I cannot see the reading of thermometer. Correct or not? The moment it becomes transparent, I can see the reading of thermometer. Then I will note that value. Now I will add solute to it. On adding solute, what happens? Freezing point decreases, or a melting point decreases. Correct? Response, sir. So when melting point decreases, again I will heat it. and I will study the temperature at which it will start melting after adding solute. Again, I will note that value. So I will calculate delta TF value. Clear? Response, sir. If I have taken water in it, if I take water as a solvent, then I should not heat. I have to cool it. Reason? At water freezes at 0. If I add NaCl to it, that mixture freezes at -4 or -10. Correct? Its freezing point decreases now, so I need to decrease the temperature of it. So instead of heating, in this glass beaker, I will take ice cubes. Clear? Understood or not? There I will go for decreasing the temperature of it further, based upon the type of solvent I have taken. Clear? Any questions, sir? So, what I'm going to do with pure solvent as well as with the solution, melting points are noted. Melting points are noted when the components of inner jacket becomes transparent. Correct or not? Or clear? To measure what I'm going to measure now. Delta TF. After knowing delta TF, what we will do? Delta TF equal to I into KF value. KF value will be obtained from this table into again same thing. Correct, sir? Same thing or not? Better, I will do one thing. I'm copying it. Now, instead of delta TB, I write it as delta TF. Instead of KB, I will write it as KF. So molecular weight of unknown solute equal to I into KF upon delta TF into this value. So by using this idea, can you calculate molecular weight of unknown solute or not? Any questions in it? So Rast method is over, and this one is Beckman's method. Response, sir. Do you have any questions in it? Right? No. Observe this table carefully, sir. Now, based upon the table, they can frame questions. Compare Kb values of different liquids. Which liquid have higher Kb value? Which liquid have higher Kf value? Right? They may ask you questions in this way. So I am giving one data. You cannot remember all these values, right? But observe carefully. Boiling point is high. Observe Kb value. Boiling point is low. Observe Kb value. But not always directly related, right? To some extent we can bring relation, right? As boiling point enhances, what we can say? Kb value, or we know that what is Kb equation? R into Tb square by Kb equal to R into Tb square by 1000 into latent heat of evaporation, or I will write as a delta H of evaporation. Correct, sir? Say something, man. If yes, liquid's enthalpy of evaporation is high, what happens to its Kb value? Low. Water takes more heat energy to convert into vapor. Reason? Hydrogen bonding. And water can form more number of hydrogen bonds. No? So to break all the hydrogen bonds and make that water molecule free, I require more heat. Means what happens to enthalpy of evaporation? Delta H value, high. Therefore, what happens to its Kb value? Low. Clear? So the liquid with high enthalpy of evaporation will have lower Kb value. Right? Sometimes they will give this complete table. And they will ask you which liquid is having higher enthalpy of vaporization. Check the values. Which is having lower Kb value, that is having higher enthalpy of evaporation. Clear? Response, sir. If enthalpy of evaporation is low, Kb value becomes high. Observe. Organic compounds are more volatile, means they can convert into vapor readily, means their enthalpy of evaporation will be less. So as their enthalpy of evaporation is less, what happens to their Kb value? Observe 5.03 carbon tetrachloride, CCl4 carbon tetrachloride, organic solvent, na? It can convert into vapor readily. Therefore, its Kb value is high. Clear? Understood or not? So enthalpy of vaporization and Kb value are inversely related. Same way. Enthalpy of fusion and Kf value are inversely related. Respond. Any questions in that? Array, you are not responding properly, man. Today all are dead or maybe sleeping. Huh? What happened? You are all not active like earlier. Monday or today? Huh? Wednesday. Oh, you are not habituated. Huh? Your body clock was not habituated for Wednesdays. Right. Now observe this data. Observe boiling point values data. Write these things in the order of their boiling point values, which is having higher value, boiling point value. Observe which is highest. Acetic acid. So boiling point of acetic acid greater than next water greater than this is 1, this is a 2. After that cyclohexane means can I write as C6H12? Then you will write something else. But I will write like this. I will write the structure. Okay, what? Greater than benzene, then greater than ethanol, then CHCl3, then 1, 2, 3, which is 4, man. This is 4, this is 5, this is 6, sorry, this is 6, this is 7, 8, 9. Then carbon disulfide CS2, then diethyl ether. Diethyl ether is also called as what is oil of vitriol? What is sweet vitriol? Hey, sweet vitriol, man. What is green vitriol? White vitriol, blue vitriol. Blue vitriol, man. What do you mean by vitriol? Viscous fluid is called as vitriol. Right? On pyrolysis of sulfates, you will get viscous fluid. That's why it is called vitriol. What is oil of vitriol? Sulfuric acid. Blue vitriol, copper sulfate. Green vitriol, ferrous sulfate. Then red vitriol, ferric sulfate. Cobalt sulfate. Then vitriol of Mars, ferric sulfate. Another sweet vitriol, diethyl ether. Don't trust. Don't trust me. Don't trust me. What I call it as we are talking about vitriols, na? Vitriol. What is blue vitriol? Or Roman vitriol, or vitriol of Cyprus, right? What is it? CuSO4.5H2O. Green vitriol or copperas, FeSO4.7H2O. Oil of vitriol or spirit of vitriol, sulfuric acid. Red vitriol, cobalt sulfate, COSO4.7H2O. Sweet oil of vitriol, diethyl ether, just now we discussed, diethyl ether. Vitriol of arsenic or vitriol of clay, aluminum sulfate. Vitriol of Mars, ferric sulfate. White vitriol, zinc sulfate. Correct? Response, sir. So, after carbon disulfide, what we are writing? Diethyl ether, C2H5, C2H5, O, C2H5. Diethyl ether, also called as sweet vitriol. Any questions? Now, after boiling point, next data. Observe Kb values. Which is having higher value, Kb. Highest value, 1. After that, correct? Then acceptable, sir. Tell me, which is highest? CCl4 greater than CHCl3, chloroform greater than acetic acid greater than cyclohexane greater than benzene greater than CS2 greater than diethyl ether. Okay, so C2H5 twice O. Okay, diethyl ether greater than C2H5OH greater than water. Observe boiling point value and Kb value. No one will ask you to give the total order. They will ask only highest, lowest values based upon our NCERT table. Right? Which among the following statements are correct? Option A. Boiling point order of acetic acid greater than water greater than cyclohexane greater than benzene. Same way, Kb value. Acetic acid greater than water greater than benzene, cyclohexane greater than benzene. Are you able to understand? So you must be cautious. Which is having higher? Which is having higher? CCl4 among boiling Kb value, and lower value is water. So remember these two only. No need to remember remaining all. In case of boiling points also, remember these two. Higher value, lower value. No need to bother about complete order, right? Next, sir, Kf value. Before Kf value, freezing point value, which is having higher freezing point. Higher, sir. 279, 290, then 279, then 273, 278, okay. Then 273, 4, then 5, 6, 7, 8, 9. Now tell the order. Freezing point order. Which is highest? Freezing point. Acetic acid, okay. Acetic acid greater than cyclohexane greater than benzene, benzene greater than water greater than carbon tetrachloride greater than chloroform greater than carbon disulfide greater than diethyl ether greater than, yes, ethanol. That's all. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, KF values. And compare KF value, which is highest KF 20, no, 31.8. 1, then 2, after that 3, 4, 5, 6, 7, 8, 9. Now, tell the order, sir, which is highest? CCl4 or? Tell man. CCl4 or benzene? CCl4 greater than? CCl4 greater than? Cyclohexane greater than? Benzene greater than? Chloroform greater than? Acetic acid greater than? 1, 2, 3, 4, 5, 6. CS2 greater than? Ethanol greater than? Water greater than? Diethyl ether. C2H5 twice O, correct? Huh? Right, sir? Something is missing. Huh? Hey, why man? CCl4 highest, man. Maybe chloroform, I think this is. This is CHCl3, I think so. Check. 4th place. CHCl. Now, here also, lowest is diethyl ether, highest is chloroform. Acetic acid highest, ethanol lowest. You need to remember the data. This table, who cares? Who cares, man? Right? This is also only for compare. Something I missed. Something I deleted. Done. Next one, sir. 4th one. What is it? Berkeley-Hartley method. Respond. Berkeley-Hartley method is used to measure by using osmotic pressure. Right? So I am taking that. Berkeley-Hartley method. Control X. So this is Berkeley-Hartley method. Observe this carefully. This is water. Pure solvent is present here. Pure solvent. Water is present means pure solvent, right? Outside, here solution is present, correct? Now tell me, among these two, which will show more pressure? Which will show more vapor pressure? Water or solution? Which will show more pressure? Vapor pressure. Pure solvent's vapor pressure is more. So water will exert more pressure compared to solution. Right? That's why water always try to flow from here to here. Correct, sir? This is the direction of flow of water, correct? Either upward or downward, correct? Then what happens to level of water in this reservoir? What happens to water level in this reservoir? Increases or decreases? Water is flowing outward or inward? It is going away from this center tube, correct? And water is going outward, man. Water is flowing out from this tube or not, and from the center tube or not? Then what happens to water level in this reservoir? Decreases, correct? Yes. Water. Array, observe this pipe, man, carefully. Understood? Right? So this is water level. Here also, this is also water only. Okay, va? Understood now? Now what happens to water level in the reservoir? Decreases. This reservoir will have reading calibrations. Right? On this side you will have calibration, any side. Now if water is flowing into this solution, what happens to this piston? Moves upward. Right? Now what I will do is I will apply pressure, and that pressure is measured by using this pressure gauge. If I apply pressure, what happens to this flow of water? Will be opposed or not? Right? Correct or not? So keep on applying pressure till water level in this reservoir goes to its original position. Right? That pressure is nothing but pressure applied to stop osmosis process. So we call it as osmotic pressure. Correct? Response, sir. Understood or not? Now, first take pure water inside this middle tube, and outside this also take pure water. Here as well as here. In both places you take pure water. This is semi-permeable membrane. This dark one is here they have already given. This dark one is semi-permeable membrane. Right? So if I have taken pure water inside and outside, what happens to water level in this reservoir? Remain constant. Now take certain known amount of solute, add here. Known amount of solute and add here. Then what happens? It becomes a solution. Then water level in the reservoir start decreasing. Then push the piston till it goes back to its original position. Now in the pressure gauge, see the reading. Okay. Are you able to understand? Any questions, sir? So by using Berkeley-Hartley method, what we are going to do? What we are studying here, what we are doing, right? When solvent flows, due to osmosis, level of solvent decreases in reservoir. Level of solvent decreases in the reservoir. Now, what we have to now, right? Increase pressure over solution until water level or solvent level in reservoir goes to its solvent level in reservoir is back to original. Right? Then pressure in the pressure gauge is, then pressure from pressure gauge is noted. That pressure from pressure gauge is nothing but phi, which is called as osmotic pressure. Define osmotic pressure. Pressure applied on solution to stop osmosis is called osmotic pressure. Correct? Now you know osmotic pressure formula pi equal to I into what is C? Number of moles by volume. Number of moles by volume can be written as number of moles can be written as weight by molecular weight. Correct? So weight of solute upon molecular weight of solute. Respond, sir. Into ST upon volume of solution. Correct? Huh? Now bring that molecular weight to this side. So what you got now? Molecular weight of unknown solute equal to what do you get? I into weight of solute into S into T upon pi volume of solution. Correct, sir? This is how we are going to measure molecular weight of unknown solute. Now, next question is, till now we have seen 4 methods to determine molecular weight of unknown solute. Among these 4, which is best method? Right? Among all these 4 methods, osmotic pressure method is best method, particularly to measure molecular weight of biomolecules. Reason, biomolecules, organic compounds, right? Living enzymes or something like that, polymers. During elevation and boiling point, we are destroying it. We are heating beyond boiling point, na? Means we are decomposing it. During depression and freezing point, also we are destroying its structure. In relative lowering of vapor pressure changes cannot be measured so easily. Relative lowering of vapor, there also vapor pressure, na? Vapor pressure means I have to go to the temperature where equilibrium reaches. Correct? But in this method, we are not destroying the compound. So among all methods, which is best method to determine molecular weight of polymers? Relative lowering, osmotic pressure method. Berkeley-Hartley method is the best method to determine, right? So osmotic pressure method is best method to is more reliable. Do you understand, sir? Instead of saying reliable, I will write as is best to determine molecular weight of polymers or biomolecules or living cells or enzymes or proteins or amino acids, right? Among all methods, which is best suitable method? Osmotic pressure. Now, what are the things pending? Experimental methods is over. Next. Osmotic pressure. We need to compare osmotic pressure. Entropy changes is over. NCERT table, that is over. One more table. 1 minute, man. 1 minute, man. One more table. One more table. This table. Generally, they will not ask you question related to this table because it brings unnecessary confusion, right? But we must be cautious. Now see this table. Observe this table carefully. Consider NaCl. Generally, if we drop NaCl in water, what will take I value? 2, because it will ionize completely, right? But observe this table carefully. I value is 2 if and only if it is complete dissociation. Instead of that, if they give concentrations like 0.1 molal, 0.01 molal, 0.001 molal, its value is not equal to 1. Approximately close to, sorry, not equal to 2, approximately close to 2. But there is some variation, right? KCl also 2 only. NaCl is 2, KCl is 2. Observe these two values. At a 0.1 molal, which is higher value, NaCl or KCl, right? At 0.01 molal, KCl. Is there any change or not? At 0.01 molal, same. Based upon this data, they may frame a question. Are you able to understand? Is it clear? Right? It is the data given from NCERT. That's why based upon this table, they may frame a question. You must be cautious. Right? At 0.1 molal, at 0.1 molal, I value of NaCl is greater than KCl. At 0.001 molal, I value of KCl is more than NaCl. At 0.01 molal, both are equal, right? Most of the cases, they will give question based upon this. Reason? No confusion. There is no confusion. If they want to make you do mistake, wantedly, if they want to frame a question so that everyone has to give wrong answer, then they will give you comparison between 0.1 molal of NaCl versus KCl, 0.001 molal of NaCl versus KCl. You must be cautious. Clear? Response, sir. For MgSO4, K2SO4, no confusion. Reason MgSO4, how many ions it will give? 2. K2SO4, it will give 3. Obviously, number of ions of K2SO4 is always greater than MgSO4, no confusion. But only problem is NaCl and KCl both use 2 ions only. Right? You must be cautious about these two values at 0.1 molal and these two values at 0.01 molal. If they give 100% ionization, instead of saying concentration, if they say assume 100% ionization, always values become 2 only. Clear? Respond. So you must be cautious about the data, which was given in NCERT tables. If they have not given this table in NCERT, we might have not studied it. As they have given in it, they may make question so that everyone can give wrong answer. Clear? Or if you don't read this data, what we generally do, I value we will take it as 2 only, na, for NaCl or KCl. Now we should not take it 2. You must be cautious. Clear? Response, sir. Response, sir. Clear or not? Right? What is the next one we are supposed to discuss? Osmotic pressure. Osmotic pressure. This is also present in your NCERT textbook, sir. Just let me open it. Here. Read this carefully. Osmotic pressure of cellular fluids in bloodstream is approximately equal to 0.9% weight by volume of NaCl osmotic pressure. So osmotic pressure of 0.9% weight by volume NaCl is exactly equal to osmotic pressure of bloodstream. So as both osmotic pressures are equal, we call them as isotonic to each other. So this pi 1, this pi 2, both are equal. That's why we call it as isotonic, right? If a concentration of NaCl, if it is greater than this value, right, then what happens to its osmotic pressure value? Becomes greater than cellular fluid. Correct or not? If this concentration is high, if concentration increases, what happens to osmotic pressure? Increases, no? Correct? So if a concentration of NaCl is greater than 0.9%, then osmotic pressure of such a solution becomes greater than cellular fluids. Then we call that as hypertonic NaCl solution. If it is hypertonic, what is the direction of flow of water? And if concentration is high, what is the direction of flow of water? From cell to NaCl. Correct? Then if water flows from cell to NaCl, what happens to all the cells present in your bloodstream? Will shrink and they will be dead. Correct or not? Water flows outward from cell and cells will shrink. Correct? If concentration of NaCl is less than 0.9% weight by volume, then we call it as hypotonic. This is hypertonic, then I call it as hypotonic. If NaCl concentration is less than 0.9, if it is hypotonic, then water flows from NaCl to cell. Then what happens? Cell will bulge, right? Water flows inward of cell and cell will swell, bulge, right? Correct or not? Now, people consuming more salty food, if you are consuming more salty food, right? They are affected by edema. What do you mean by edema? Your feet, legs generally will swell more. Just a moment, I will show it. Edema. Observe that feet. Observe this. Right? No. Till that concentration of NaCl, if it gets balanced, again they will decrease. So we call it as edema. Right? Are you able to understand? So what happens during edema? Also known as swelling or fluid retention, is a condition that occurs when fluid builds up in body tissues. It can affect the entire body, but it's most common in legs, ankles, and feet. Right? Are you able to understand? It is getting increased in tissues means, what is the meaning of it? Water is flowing into the tissues. So concentration of NaCl is decreased, low. Correct? Response, sir. In cellular, in normal blood stream, not inside the cellular fluids. Clear? Response, sir. Response, sir. Any questions in it? Edema, if more salt is consumed. Yes, sir. Yes, sir. Go, sir. Go, sir. Consuming excessive salt can lead to edema. If you are taking more salty food, then it leads to edema. Reason: body will retain water. Instead of excreting water, water will be stored in it, inside the body. We are not going to excrete water, not neither in the form of sweat or nor in the form of urine. Right? If you take more salt, water will be stored inside your body and in tissues. That leads to fluid buildup in tissues, especially in legs and feet. We call that process as edema. If you don't consume salt, again it leads to another problem. What happens? All cells will wither and all cells will die. So that's why we need to balance salt intake. So then who will decide how much salt will intake? Tongue. Tongue will decide. Right? Your body will reject it. If you take more salt, your tongue will not allow it to accept it. If it is low also, your tongue will say, add some salt. That's what we call it as a taste. Right? Understood, sir? Any questions in it? No. People consuming more salty foods are affected by edema. In case of pickles or meat, why we are storing that in salt or sugar? If you store that pickles in salt, more concentration of salt. So outside concentration is more. Then what is the direction of flow of water? From fruit to outward. If water flows from fruit to outward, there is no water content inside fruit, means bacteria cannot grow. So even if a bacteria is present inside fruit, it will die. Then pickle will be stored for longer time, correct or not? And it will not get rotten, right? Response. Now, what do you mean by reverse osmosis? If you apply more pressure greater than osmotic pressure, reverse osmosis takes place. That's what we have seen. Clear? So I am taking this data as it is. Which one? This way. Particularly cellular fluids here. Any questions in this? Here what I discussed. Osmotic pressure is best method, more suitable to determine molecular weight of polymers or biomolecules. Best suitable method. Clear? Response, sir. Any questions in it? Online, do you have any questions in this?
No, sir.
No, sir.
So we have done officially with solutions and colligative properties chapter. Now open your target booklets.
Sir,
need to
the
start solving
science
questions.
questions, sir.
Yes, those questions also we will solve. Yes. All right, first we will solve those questions. First we will solve those questions. Just a moment, let me adjust this a little more. Now I will post the complete notes, man. Right, old notes I am deleting, sir, and I will update this new notes. Okay. And both are same only, no much difference. But if you see that notes, what we have discussed right now, you will have some continuation. That's why I'm removing old notes and I will keep this new one. Okay. What I will do is I will do that adjustments and I will update in by next class, right? Now coming back to these questions, right? Right. Start, sir. Question number 10, sir. Those star mark to those questions. Question number 10, sir. Vapor pressure of solvent decreases by 5.4 torr when a non-volatile solute is added. In this solution, mole fraction of solute is 0.2. What would be the mole fraction of solvent if a decrease in vapor pressure is 16.2? What they have given? Vapor pressure of solvent decreases by 5.4 when a non-volatile solute is added, means delta P, correct? Correct or not? Vapor pressure of solvent decreased by 5.4 torr. Decreased by 5.4 torr means delta P or not? So delta P is equal to 5.4 torr. Right? Now, Let me do this. In this solution, mole fraction of solute is 0.2. Now means here, mole fraction of solute means A is 0.2. What would be the mole fraction of solute if decrease in vapor pressure is 16.2 torr? Means if delta P equal to 16.2 torr, then what is XA equal to? This is the question. What is the formula, sir? Delta P equal to delta P upon P naught equal to what they said? Non-volatile solute means I value. Non-volatile, and do they mention anything about ionization? Ionization also not given. So what is I value? 1. So delta P by P naught equal to I into Na by Na plus Nb. Or okay, I into Na upon I into Na plus Nb. Correct? Correct or not? I value I have taken as 1. Now substitute. What you will get? Observe carefully. What you get? Delta P is directly proportional to XA. Delta P is proportional to XA only, na? Delta P equal to P naught into XA. So delta P is directly proportional to XA. So delta P1 by delta P2 equal to XA, X1 by X2. Correct? So what is X1 or X2? What is value? 5.43 times means 0.2 becomes 0.6.
Sir, solvent they have asked. So
Right.
1 minus 0.6.
Oh, they want mole fraction of solvent. Okay. That is also over. 0.4. 0.4, man. Correct? Say something. Say something. Any questions in it? No. Come to next question, sir. What they are asking. So better I will write here. Delta P is proportional to XA. Delta P1 by delta P2 equal to XA1 by XA2. Problem solved. Solve this question next one. For a dilute solution containing dilute solution means I can assume Na plus Nb as Nb, correct? Containing 2.5 grams of a non-volatile non-electrolyte solute in 100 grams of water. Elevation in boiling point at 1 atmosphere is found to be 2 degrees centigrade. Assuming concentration of solute is much lower than the concentration of solvent, vapor pressure of the solution is. Again, for a dilute solution containing 2.5 grams of non-volatile non-electrolyte solute means I value 1. I value is 1. What is weight of solvent? Weight of solute. Weight of solute 2.5 gram. Weight of solvent 100 gram. Response, sir. Right? Now, elevation in boiling point at 1 atmosphere pressure is. Elevation in boiling point at 1 atmospheric pressure is 2 degrees centigrade. Delta TB is 2 degrees centigrade. Assuming concentration of solute is much lower than concentration of solvent. What is the meaning of it? Concentration of solute is much lower than concentration of solvent. Vapor
Sir,
pressure of solution is.
sir.
Yes, madam.
Do they mean that it's a dilute solution, sir?
Obviously. That's what they mentioned in the first statement itself. Right? Okay, well, means number of moles of solute is far less than number of moles of solute is far less than number of moles of solvent. Means Na plus Nb I will write as Nb only. Now what I have to calculate? Vapor pressure of solution. How I will get vapor pressure of solution? Means I need to calculate PS. How I will calculate PS? Right, sir. Clue also I will tell you. Clue also I will tell you. I highlighted a clue, sir. Done. What, sir? Can you calculate molecular weight? Delta TB equal to I into KB into molality. Correct? So what we will write? Delta TB equal to from here. Delta TB equal to I into KB into molality. So what is delta TB? 2. I value 1. What is KB of solvent given? 0.76. Yes, sir. Into molality. Molality. Weight of solute by molecular weight into 1000 by weight of solvent. Weight of solute 2.5. Molecular weight we don't know. Into 1000 by weight of solvent 100. Means we are calculating molecular weight of unknown solute or not. Right? Now what is this value? 25 means I can write 100 by 4. 76 by 8. So molecular weight equal to 76 divided by 760 by 8. Correct? Response, sir. So what do you get? 9s are 72. 9.95. Array, what I have done? 2.5. Oh, okay, okay. Correct only, na? 2.5. Oh, 9.5 only. 9.5 only, na? Not 95. 9.5 only. Right. I am writing 2.5 into 10 as 25. I am writing 25 as 100 by 4. 102.76 is 76. Divided by 4 is there now. I am bringing 2 to this side, molecular weight to that side. So what do you get? 76 by 8. So 76 by 8 is 9.5. So I have got now molecular weight of that solute as 9.5. Now next point. P naught minus PS by P naught equal to I into Na by I into Na plus Nb. Relative lowering of air pressure. Right? P naught minus PS by P naught is equal to I into Na upon I into Na plus Nb. Instead of that, we can also write in another way. PS by P naught equal to PS by P naught equal to NB by Ne. Mole fraction of B na NB by Na plus Nb. NB by Nb. Listen. Don't get confused. This I am writing it as 1 minus PS by P naught. Correct? Can I write like this? 1 minus PS by P naught equal to XA. Right? Bring this to this side and XA to this side. What will you get? 1 minus XA equal to PS by P naught. What is 1 minus XA? XB. XB equal to PS by P naught. What is XB? NB upon Na plus NB is equal to PS by P naught. Correct, sir? Correct? So, Na is negligible. If Na is negligible, what is NB by NB? 1. If NB by NB is 1, then PS is approximately equal to P naught. Correct? So, either I can use that way or this way. Both are same only, nothing variation, no variation, right? So, okay, I will not make you confused. Let me use the same formula. What is P naught? What is pressure given? Then P naught becomes 760 torr. Right? At boiling point, man. Elevation in boiling point. Right? So at boiling point, what is vapor pressure of pure water? Assume concentration of solute is much lower than the concentration of solvent. The vapor pressure of the solution is, right? Vapor pressure of the solution only, na? Vapor pressure of the solution we need to calculate. Means PS we need to calculate. Then what will be P naught? 1 atm? Are pure solvent, man. Yes or no, man? Say something. Right? What you will get now? Delta P by P naught is equal to Na. What is Na? 2.5 by 9.5. Right? I will write that also. I will write that point. Number of moles of A equal to weight by molecular weight. What is weight? 2.5. Molecular weight 9.5. Which is nothing but 25 by 95. Right? Then what is XA? Na upon Na plus Nb. Correct? Right or not? So Na is 9.5, sorry, 2.5 by 9.5 upon Na plus Nb. What they mentioned in the question. Assume concentration of solute, means number of moles of solute is much lower than concentration of solvent. Right? Means I can assume XA value is much less than XB value. Means XA value is approximately 0, XB value is approximately equal to 1. That is the meaning of it. Right? Okay, whatever it may be. Let me write here. So directly can write only number of moles of B now. In the denominator, what is number of moles of B? Weight by molecular weight? 100 by 18. Means what is XA equal to? 25 into 18 upon 9500. Okay, 95 into 100. 25 fours are 2 nines are 9 divided by 190. Now substitute that value here. So what you will get now? That implies 760 minus PS is equal to 760 into 9 upon 190. Response, sir. Let's say something, right? So what is this value? 90 and how many times? 4 times, huh? 4. 9 fours are 36. Therefore, PS equal to 760 minus 36 is approximately equal to 724. Correct, sir? So answer must be 724 or then you will get deviation. You will get something wrong. Reason. There we are not doing any negligence. We are not able to neglect anything. We are getting accurate. Then I need to use this data. No? To use this data, I have to do it. I don't have any choice. Clear? Response, sir. Next question. Online. Are you following or not?
Yes, sir.
Someone sent some message. Sir, option 1. Okay, option 1 accepted. Question number 15. Hey, you want to copy, huh? No need, no? Understood, no? Later we copy. Practice it. Question number 15, sir. Question number 15. Thank you. 22, 11, 33. Sir, many students are absent, man. Why you people are not coming to classes? Afa came, Nora not came. Nora, are you available? Nora is not there. Kalni, Tushimalagam, Jilgan, Sri Vaishnavi, okay, Santoshini. Many people are not coming to classes. What this is? Josiah Moses, not there. Mukil, Niveshinin. Oh, Niveshini. Oh, she shifted to weekend, no? Santoshyam, you are here, okay. Santoshias, Shiva Santoshias, not there. Tanish, you are here, okay. Kritik, Muthuvel, you are here, okay. Muhammad Saifuddin, Janita, no. Tharun Krishna ji, Josiah Moses, Nora, Ariz, no. Naresh Balachandran, not there. Harish Kumar, Sevarinathan, Pramod, Gautaman, Harivarshan, or Harivarshan, okay. Vasumati, Lohit, Srinikesh, Sai Vignesh, Sai Visagan, Aditya, you are both, Aditya is here, Akhilesh is also here, both are here. Arun Bharati, you are here. Mithun, these last people, most of them are absent only. Solve. Online students, I am closing this lecture, man. You join in the next link because I am not able to take the attendance online. You join in the next link, sir. Second
Okay,
link you join. All right. I am closing this lecture. You join in the next link.
Okay, sir.
Madam Vishandi, Sivakumar, Sabarish. Join in the next link, sir. Sabarish, Veeranan. Yes. Sivakumar, Sabarish, Veeranan. Join in the next link.